Hello students. We discussed in previous videos on use of manipulators how to use set W left and right and set fill manipulators. We are going to use that technology now to read a input file that has data about the inventory in a hardware store. We're not showing too many items, just 3 items. And the program that we wish to write should process that input file and should process a inventory table in the tabular form to an output file. We're going to show you both. So we're going to write a program which reads inventory data from an input file and prints a table of inventory report to console and output file. And now let me show you the input file, and it could really have many different versions. I'm going to just show you one version. So this is the inventory file here. It has 3 items, and I'm not sure the font wise whether you can see it or not, but this line gives name of the item, hammer, how many there are, like 100, and price of each item, and the nails, 10,000, price 5 cents each nail, chisel 500 in inventory and price $5.99. And you could add more items. They don't have to be in different lines. They could be in the same line if you like, but they could be in different lines if you are saving this inventory file in a Excel spreadsheet and then you save a tab delimited form of it. So otherwise they could be in any form, doesn't really matter, although having them in one record per line would be more convenient. The goal is that a program should read this file, and don't forget there's an UF character at the end of each file, and certainly we will use a UF loop, which I've taught in the class earlier, and we'll probably look into it again. Will be used to process this file, but really our goal is to get a inventory report in this form where there's a name of the store, and then we have a header line, header row, which gives the item name, number of units for that item, cost of each unit, and total value for that item. Okay, and then finally we compute the cost of the inventory, which is a piece of data that stores find very useful. Okay, notice the characteristic of this table that items are left justified, and it may not look like here number of units are not left justified, they're right justified because they're lining up onto the right, and the spaces are padded with white space. More interestingly, unit cost, the decimal point is lining up, and all data has 2 decimal points. We can easily do that using set precision. And same thing with the total value. There's a right alignment and there's a decimal point lining up. Same thing here, there's a right alignment and decimal point lining up and lining up here. This is very important. You don't want decimal points to be not aligned. That looks very ugly. So it's not a pretty table, but it still looks pretty good because we have a very good format here. Okay, so we really need to learn how to get from here to here. All right, so we're going to go to our Xcode, and the code I have is a huge code, but I'm not only going to show you the portions of it, portions that are interesting to us. Other portions are hidden, by the way, and you will get a copy of this whole thing, and you can read the portions that are hidden and ask me any questions about that. I'm only going to do what is just necessary to process the input file and get an output file in a certain format. So first let's look at our includes. You definitely need IOStream. You need fstream because we are reading from an input file and outputting eventually to an output file. We need IOManip because we're going to use setW, setPrecision, and setFill. And we are using a string because, as you know, when we read from files, we need to store file name in strings. And of course, in this case, one inventory item is the name of chisel, hammer, etc. So we need a string for that. And we need sstream because we're going to use oString object to store our output, from which we can get a string later and output that to output file and to console. Okay. So first we have this information will not be printed to output file. This is just printed to console, and this program will create an inventory report where input file has following data format, 1 record per line. So in this format, that there's a part name, could be some space, number of units, more space, and unit price, and this is repeated many times. And part name is one word. We have not provisioned for multiple name part name, multiple word part name, but that can be changed. We just didn't want to go through that right now. Okay. So since we are going to read from input file, first thing we do is we create a ifstream object called input and a file name string called infile. And basically, I have a loop here which is hidden from you, but it will be available in the whole full code that you get, which basically keeps the user in the loop as long as the file name is wrong and if file is empty. Both cases, the person will be in the loop. They can only get out of the loop when file name is correct and file has some data in it. And in that case, we'll have a cout that file has been opened successfully and has data in it. They won't get out of this loop until file exists and file has some data in it. And we could have done this later, but we did the same thing here because we do have a loop for that too. There is an offstream object here, and this loop gets from the user the output file name. Same thing happens here. This loop gets the input file name and keeps them in the loop until file exists and has data in it. And same thing is done here. This loop keeps them in the loop until they give correct a legal output file name. And this is a interesting loop. You should take a look at it. And once they have that, they will get out of the loop and program will proceed from line 94 and onwards. Okay, one thing I want to say about output, when you output, similar technology is used to output to console, file, and oString object. It's convenient to output to oString object because from there we can use the same object to later print to file or console. I have a lot of comment blocks here which do actually output to file and console separately. You can read that. But since I'm using oString object, that would not be necessary. Okay, so basically we declare all our output to oString object and use that later to print to file and to console. Okay, so since I'm going to be using some floating point data, I apply to oString object OS the fixed, the show point, and the set precision 2. So all the floating point numbers will be formatted in the mantissa to 2 decimal point, which means the cents that we are going to be outputting. Okay, this is lines up to here, print the header information, which you saw earlier in the output file. So really up from here up to here is the header. All right. Now I must say that spaces in this line are jerry-rigged. Okay, they're jerry-rigged to align what is coming later on, where we use the set W and set fill and all those things. But this could be done more scientifically, provided we store everything in a string and we know what the lengths are and so on, but we are not going to go through that now. So just understand that after outputting your data, which uses set fill and set W's, you can always jerry-rig this header so that your data is falling under columns that you jerry-rigged here. Okay, I'm not going to tell you what the scientific method is, not right now anyway. I could probably do it later. Okay, that will require a whole different program basically, but it can be done. Okay. All right, so if we look at the file, and I'm running a little short on time, already 11 minutes. So maybe I have to do this also in two parts. This will be part 1, and yeah, so I'm gonna wait, basically do the part 2 on this also. So understand that we have covered up to the point where we printed the header to the OStream stream object. Now we do need to learn how to process the file, and that requires a loop that we have here. Inside the loop we are going to read one record and print data relative to that record, and then do the second record and third record until end of the file has been reached. Okay, so I'm going to close on part 1 of building C++ program, reading inventory data from an input file, printing a table to output file. Part 1 is done. I'm gonna see you very soon in part 2. Okay, so we're gonna come back for part 2 very soon.